PA0HRK on the use of the solar cooker antennas for 3 and 6 centimeters. Harke was born in 1953, an old guy like me. And he got fascinated by radio when he first opened the all-transistor radio his father had bought him when he was about 10 years old. His fascination has since never left. He started his radio career then by dismantling tube radios and the construction of transistor circuits. In order to better understand the RF technology, he decided to study electronics and control theory at university and completed an MSc in 1982. During his studies, he became licensed as PA0HRK and started building radios for the various bands from 80 meters to 13 centimeters. He's now playing with the higher microwave bands, and about 20 years ago he became interested in EME and got on 1296 with a 2.4 meter stress dish, kind of on the design that LK2UIH had done. And then he's built some additional equipment, including 6 centimeters. So his focus is on building and optimizing radio equipment and maintaining a fine collection of RF test gear. Please welcome Harke.
Thank you, Barry, for this introduction. After the professional talks we have seen, I will bring you a little bit more amateur stuff for 6 and 3 centimeters, you will see. There was quite a bit discussion going on the so-called cooker dish, and I think most of you will be at least theoretically familiar with it, but the application was basically on 23 centimeters, and you can refer to the PA1GT website, which is very extensive on this topic and other topics, I have to say. And I read it with really interest, but I already have a system for 23 centimeters, so that didn't immediately trigger my interest directly. But then I learned that the sun noise reached at 3 centimeters could be around 11 dB, and then I thought, maybe I can use it. His conclusion was that the 1.5 meter dish would be fine for any band, well, from 1 to at least 10 gigahertz. And as I was already planning a system for 6 centimeters, I decided to change plans because originally I had an offset antenna, but to change plans and to test the sun cooker. And it was described as a cheap antenna, and you can easily set it up. So let's see if that is true. Well, to be honest, it was not so easy to procure one. Amazon and eBay and you know what, they will sell the antenna, but it is not easy to get one in Europe, at least not in the Netherlands. I don't know why.
Switzerland is so difficult.
The first order was cancelled. The second order was cancelled only after a couple of weeks. I got my money back, no complaint. And only the third purchase was a success. Well, at least partially, because you can see there's a hole in there and there is a dent in there. So one of the petals was damaged and the other one were fairly good. But I thought that's the only thing I have. I can buy another one, but that won't bring me much. Well, maybe another petal that's good, but that was not my intention. So let's see how it performs. And the antenna arrived late autumn, and at my position in the earth, on the earth, the sun is low, and it was impractical to test the antenna the way it was originally meant to be. There is simply no or too low sun, but I really wanted to test the original application. So this springtime, sun was high enough and strong enough, and oh, wrong button, of course. And it's amazing to see a piece of wood here sets fire immediately. So in fact it's dangerous. No, really, it's to me it's a dangerous toy. And but then I decided it's tea time, so I put it back. And you will be surprised how fast it will cook. It will cook the water, boil the water, you have to say. But if you calculate, it's well over 2 kW in power, and it's really strong. But so far for the initial experiments, we have much more work to do. So, what is interesting, not many people know me as an active EME amateur. And the reason is that all my equipment is always indoors. I do not make equipment for permanent outdoors. So I am what generally is called a nice weather amateur. And it means that you see here, this is the room where the antenna is located. And when I want to operate EME, I carry the whole business outside to the balcony and then make use of a limited window, moon window. The system I use was from a 23 centimeter stress disc, and what you see is here is the azimuth motor. This is the elevation, how do you call it, actuator, satellite actuator, and I just attached the sun cooler to the existing system. So you see kind of an odd rod, so to say, here, but that is used to carry my 23 and 13 centimeter feet horn. And but now the rod carries the 6 centimeters front end, or a complete transverter, and it means that that is the, well, field disturbance that I have to accept. But I don't need struts to the edge of the dish. The motors are controlled by a homemade controller from a BeagleBone computer and Python software. And well, I didn't try to repair the dents in the first place. Let's first see how it works. It's not so easy. It's very thin metal plate, metal sheet, and how you can repair that is not trivial, I think. And I have a rather small moon window, unfortunately. But let's go to the transverter first. Here we see how the transverter is built up, and well, it's a contraption, so to say, but it works. We will see that. This is the feed horn, and we will move on to that in the next slide. But you will see the connection to the low noise amplifier, and below the low noise amplifier is the local oscillator, and the local oscillator is stabilized by 10 megahertz OCXO, and it's absolutely stable enough, OCXO. It works perfect. And central here is a 6 centimeter filter, and that was given to me by PA0HRK, a friend of mine. Unfortunately, he is, well, at least 30, 40, almost 40 years ago he died. But I had to do something with the filter. So whatever happened, I need to make some sort of system for 6 centimeter as a kind of a tribute to him. This one. Here we see a little bit more of the feed horn, and this is kind of a Mercedes star, you could say, the Merc star, which is used to carry the so-called S12 disc. There is a lot of publication on 23 centimeters, the size, the position of the disc. Originally, I was very hesitating to use a disc because if there is a bird sitting on it, or the temperature changes, or whatever, you will lose immediately your S12 or S21 if you want. Sorry, Yes, yeah, no, it's correct. But I decided to use it here because it improves my S12 by about 9 dB, so it's really necessary. It's just a nut. It was what I had. I tried it. It improved by 9 dB, so I decided to stay it that way. And well, that's the story of the Kumar feed. So this is my operating system outside. You see, it's a balcony, and this wall is limiting my window, my moon window, rather. But it's the shack, so what can you do? I can't tear it down. So I have to accept, and I think the moon window I have is about from, well, 180 to 240 degrees, so it's not really much. But, oh yeah, and another disadvantage of the system is that when I put it on the balcony, you're never sure that the mechanical setup is exactly the same as a couple of months, weeks, days before. So I have to calibrate my system always on the sun. That's not difficult, but I need sun before I can track the moon. And here we see the first hot-cold measurements. It's done with a front cube dongle and a spectra view. I think most of you will know that. And the noise you see. Here we see the sun level of noise. Here we see the cold sky. I use a spot in the sky from VK3 so it's pre-defined in my controller. So I have a push button cold, I have a push button sun, moon, park. That's very easy. And what you also see is this is the wall of the shack. That's my park position. But it also gives an indication whether the system works. And VK3 predicts 8.8 dB. Well, that's not what I get. I get about 8.3 dB, but for the moment I'm happy with it. Just half a dB. If you see the setup, can't complain, I think. And there is a funny spike over there, just to mention it. Here you see a spike. And I don't know what it is. It's only on 6 centimeters. I'm not aware of radar signals or
Wi-Fi?
sorry?
Wi-Fi?
5G.
5G
Such spikes? Wi-Fi?
Carrier
5G.
or the
No, it's really a spike in the sense that most of the time it's not there. And
It's a weather radar.
yeah, is that
Okay.
okay?
The rain detection.
Yeah, that's what at 23 centimeters I'm used to radar interference.
No,
but,
it's on 6 centimeters.
okay, but this is only sun noise. We want to go one step further. Oh, I already said moon noise is about 0.2 dB. I did the first receiver test with Young, PA0HRK, and it's always happy to, I'm always happy to find a station with enough power to guide you through all the nitty-gritty work of EME. It's not just your hardware must be okay, but you must also press the right button on WSJT, and you're a bit excited because you want it to work and you don't know. You recognize. So this was really interesting. It's difficult to see for you, I think, but there's really a signal over there. And this was before installing the power amplifier, because I insisted to have Eric's first. I really wanted to know the receiver works, everything works, and then it makes sense to install the transmitter. But his signal was -15, and there's nothing wrong with that. So, this is just a picture of my operating position. You see, I use an FDN Duo. I'm not going to discuss any SDR capabilities. For me, this works. And the funny thing about the FBM Duo is that it works directly on 2 meters. So I only use some filters for 2 meters and in undersampling, but it works fine. And the filters are there, including a Wenzel OCXO, but it hardly brings anything, but well, just for fun. This is my homebrew antenna controller, touchscreen, Python program that's very nice, because I'm happy with it. Here we see the power amplifier. Maybe you have seen the article in Dubus a couple of years ago. I wrote an article about it. These amplifiers are used as a first-person view drone controller, but also as a jammer. And the funny thing is that, well, maybe you can recognize, but this is the jammer part that you have to kill. You see a double driver stage and a single gallium nitride power amplifier. I have to say that almost 7 years ago, I think, I built gallium nitride amplifiers for 3 centimeter, and it was not possible to buy Chinese FETs by the time, or it was possible, but they could not match the US FETs. Now I'm quite surprised by the capabilities of this gallium nitride FET, which of course is not from US manufacturer. Well, output power 50 watts at 30 volt. It's a really nice, capable amplifier. The gain is 38 dB, so I don't need a lot of amplification. Well, somebody reported instability in non-50 ohm loads. Well, if you know feed horns, the load, the S11 of a feed horn is terrible. So only exactly on your frequency, fine-tuned, and everything else is horrible. So you need absolutely a stable amplifier or a power isolator, but well, you lose. It's better to have a stable amplifier anyway. The models are still sold on eBay, but on a different model number. But I have looked a couple of days ago, and they are still there. This is just to show a little bit how the amplifier performs, input power versus output power. There is a little bit saturation, of course, here, but for our application, which is purely digital, it doesn't make a lot of difference. It's fine. Well, now we have the SSPA installed. This is the big heatsink and the small amplifier. There's a short cable to the feed horn, and the rest of the system is the same. And I had immediate success, in fact, because everything was prepared, and Jan came with his signal.
The champagne too?
Sorry?
The champagne too was prepared?
The champagne was already in the fridge. I have to confess. But I could decide not to open.
Okay.
That was a hard decision. But he came up, and I just switched enable TX, and then I sat, and it happened. He heard me, and I was really happy. Yeah, you can imagine. So more 6 centimeter coolers followed. It was already last week, so I was a little bit under pressure because I wanted to present a working system and not just sun noise. But it worked. The signal reports are on average minus 15 to 17, and I don't know a lot about the echo mode of WSJT-x, but it was minus 23, and I have to look at it. I don't know. I have only 2 slides for 3 centimeters because I was so focused on 6 centimeters that I was not very, well, I do not have much results, but you want to have lunch, so I will not talk about too long. But the idea is that it's a similar structure to mount the transverter. In this case, it's only a receiver on that rod that you have seen. It's not very sophisticated, which means that the results are a little bit, well, so and so. You see, I have a very simple but effective pipe filter on 3 centimeters. Here you see the input section, which is an isolator, an amplifier beneath, a marquee mixer, and this is again the OCXO at 10 megahertz. It's also absolutely stable enough for EME work on 3 centimeters. And below is a phase lock oscillator producing the necessary 10 to 4 megahertz local oscillator. Well, you see it's really experimental. This is the front end. You see the Kumar feed here. This is supposed to be a low noise amplifier. It's 1 dB, it's not very good. And another amplifier before entering the other side. Here I have a little bit less sun noise. It's about 8.5 dB. VK3UN predicts 9.9, so there is something to improve, but that's obvious. I found quarter dB moon noise already, and I decoded OZ1 LPR, but you don't need much to decode.
It's not QRP.
So to say, to put it mildly. But the vertical offset is about 3 dB, 3 degrees, so that's not very, it's not very accurate. That needs some improvement. But it was more meant as a toy, as a proof of concept. But the 6 centimeters is really something that I want to accomplish. Well, I don't have a real conclusion apart from the fact that it was fun, and I liked it. It worked. And maybe in the future I can work many of you with 6 centimeters. Thank you. Questions?
Very quick one.
Yes.
The fact that you've got echo mode to work on 6 centimeters means you can work all stations of the same size, which is congratulations in the extreme.
Thank you. Accepted.
How was the weight on the feed horn on 6 centimeters? You had a big heat sink. I know those things weigh. Were there any problems having the weight out there on the end of that pipe?
Absolutely. And that's one of the reasons that each time what I do now is when I install because it's the tripo that is what I put out first. Then the elevation system. Then the dish itself. So it's a lot of assembly. So now then I have the hole and I attach the transverter. But I use a level because I know I have 2 degrees of freedom. One is on the pole, but I put a screw on it. So I know exactly how far I have to push the transverter. But then it can wiggle. So I need a level, and then it turns out to be fairly good, but there is some sagging, and I try to compensate that when I adjust the system or calibrate the system on the sun. So that's one of the reasons that I always need the sun to calibrate my system. Is that an answer to the question?
Well, that's an answer, but I think that with the bending in the pole, that's going to change on your elevation and things like that. So that's
Oh, that's too
problematic.
sophisticated. It's true, but
Very well.
it's absolutely
You're in
true.
your own beam width,
Yeah,
so
yeah, no, it's
it's-
absolutely true. But I've also seen that my azimuth is not 100% correct. So what I plan to do is for a future round with the software to make some kind of table to correct it. Yes, please.
And tell me, do you keep the dish assembled? So means the dish.
Yeah, completely assembled, yeah.
How do you manage with your wife?
She helps me.
Wow. Good.